Alrighty, welcome back to experimental design. We are talking about how we can design an experiment and what scientists do. So the last thing that we talked about in the first set of experimental design notes was identifying the IV and the DV. Pause it right now and announce to your room what's an IV and what's a DV. That's right. An IV is the independent variable, and it's the thing that the scientist changes. I change. The DV is the dependent variable, and it's the thing the scientist measures. So now we're going to move on. Now that we've identified our IV and our DV, we can write a hypothesis. Because the great thing about experimental design is with that if-then statement, it's if something about the IV, then something about the DV. So number one's already been done for us. The IV for our first design, this was that student of mine that was had the bouncy ball as a gift and wanted to see whether temperature affected it. So temperature was his IV and how tall it bounced was his DV. So that means that everything that comes after the if statement needs to be something about temperature. And you can see it says if the temperature of the ball is hotter. Now, we also could have put colder. It doesn't really matter as long as it's about temperature. Then the next, we got our comma and then our then statement. And we can see that our DV is bounce height. So we know that something about bounce height needs to come down into our then statement. So then the ball will bounce higher. We also could have said the ball will bounce less or lower. Right now, I don't care about whether or not you are guessing correctly about what will happen. What I care about is whether you can identify where the IV goes and where the DV goes in an if-then statement in a hypothesis. All right, let's do one more together before we make you move on your own. So this next one is the same one we've been talking about. The IV was soil type and the DV was seed germination. Real quick, what was germination? Right, when a seed bursts out of its seed coat and gets that little bit of stem and a little bit of root coming out so it can get ready to go. So our first statement is going to be if something about soil type. We got to write something about soil type down here. Well, we can't put if the soil is type. That doesn't make any sense. What types of soil are there? What kinds of ways can you describe soil? That's what you need to be thinking about. It could be sandy soil. It could be rich soil. It could be expensive potting soil. It could be cheap dirt from the backyard. It could be silty soil. It could be wet soil or dry soil, whatever you think, but it's got to be some type of soil. It's got to describe the soil. So we're going to go with sandy. So if the soil is sandy, then, so now we need to do something about the seed germination speed. Now, I am going to go ahead and put on my thinking cap. I could write whatever I wanted. The seed will germinate faster and be done. And for me, you would be correct. But, you know, it's science class. Let's learn. How much stuff grows in sandy soil? You've been to the beach. Are there lots and lots and lots of things growing out there? Are there farms out there at the beach? There's a couple cotton farms as you get closer, but not right there at the beach in the sand. So if the soil is sandy, then the seed will germinate slowly is the correct one. But if you didn't say that, that's okay. All right, I want you to pause the video and I want you to answer the next two, the third design and the fourth design. You're going to think about string length and its effect on how often the string swings back and forth. And on the last one, you're going to be thinking about food type and amount of food eaten. And remember that we're talking about the geckos there. So don't put in like pizza and SpaghettiOs. It needs to be stuff that the geckos will eat. Fruit, insects, things like that. All right, pause it. And then Mrs. Anderchek's going to come give you the answers.
Okay, you should unpause now that you've answered those. Our third design is about the IV. The IV is string length. So our string length, well, we can say it's short or we can say it's long. So I'm going to say short. So if the string is short, then we need to say something about the cycles per minute. So I'm going to say that the cycles per minute are fewer. You
can abbreviate it as CPM if you like.
Excuse me, that's a T. The cycles per minute. Cycles per minute. That's a short way of saying it. CPM are less or fewer. Either way is right. Okay, so the cycles per minute are less or are fewer. So if the string is short, the cycles per minute are fewer. Okay, let's look at the next one, number 4. All right, so our IV is food type. Well, let me think of a type of food that a gecko would eat. Well, I know geckos eat fruit, so I'm going to go with fruit. So if the gecko eats fruit, then how much food do you think that gecko would eat? I like fruit, so I'm going to say a lot. Then the gecko will eat a lot. All right, and there it is. That is how we do an if-then statement to write our hypothesis. All right, Mrs. Harris is going to come back and she's going to do the next section with you.
Okay, so now we're moving back into taking notes. So things that are kept the same in experiment are called constants. So in the last lesson, we learned that things that change are called variables. And that makes sense. I mean, if someone asks you, what's the weather like in Virginia? You're going to say, it varies. Because you know how it is. You can wake up in the morning and it feels like winter. And then by midday, it's summer. And then by the afternoon, it's fall. And then by the evening, it's spring. Like we can have everything all at once. So it varies. It changes. What about when your brother is being constantly annoying, right? That means it's staying the same. So constants are things that stay the same. And variables are things that change. For an experiment to be considered valid, meaning testing for what it says it tests for, you have to be careful to keep everything other than your IV and your DV the same. So your IV is the one thing that you are going to change, the one variable that is, you're changing it on purpose. I think that bees are more attracted to the color red. So my IV is going to be the color that I use. And then my DV is the thing that I measure. I'm counting the number of bees that come to the flower. So that's my DV. It's what I'm measuring. Those two things are going to change, but everything else needs to stay the same. So in our first example design, in the design that my student did out at New Dominion, he had the bouncy ball and he wanted to see if temperature made a difference. So what things are going to need to stay the same? All right, well, of course, the bouncy ball. You can't use a tiny little bouncy ball on one day and then one of those great big mega bouncers on another day. They're going to act differently. The environment needs to be the same. So you can't be in a windy, cold environment one day and a nice, warm, toasty environment the other day. It needs to be the same. If you're inside, you're inside. If you're outside, you're outside. The surface, the floor that the ball is bounced on. We know that the surface definitely makes a difference. Think about it. What is every basketball floor made out of? Right, wood. That's because wood actually has more bounce and more give. Think about it. When you played basketball on asphalt, how much ups did you get? Not much. So it's definitely going to make a difference. The ball's going to bounce more depending on what surface it's on.
If you put it on carpet, it sure doesn't bounce at all.
Yeah, carpet's going to absorb all of that energy and not send any of it back. What other kinds of stuff might need to stay constant in this design?
Oh, I would also say, we see what said the size. I would say if there's a texture on the bouncy ball, like is the texture of the bouncy ball the same? That needs to stay the same.
Yep. One of the big problems that my student had, we had to figure out how are we going to change the temperature of the ball, right? So he had all kinds of ideas, but the one that we finally stuck with was using water. We use boiling water, just shy of boiling water. We use just shy of freezing water, and then room temperature water. And the ball just sat in the water for a long time. So once you've decided how you're going to change the temperature of ball, then you've got to think about, well, what things need to stay constant there? So now knowing that, what might need to stay constant?
Well, we need to always use water and not other types of liquid.
And then it would also matter whether it was well water or bottled water or whatever. So we need to be careful of that. Then the amount of water used, we couldn't use just a tiny little cup for the hot and a big jug for the cold. We know that the mass of the water is going to make a difference. The time spent in the water.
Yes, definitely.
Can't leave one of them in there for 3 seconds and leave one of them in there for half an hour. All right, that's a great list. So again, pause, and I want you to come up with at least 2 things that would need to be constant in the other 3 designs, in example 2, 3, and 4. And then when you come back, we'll have, I think I'm going to do a second video because this one's getting long. When you come back to the second video, you'll be able to get those answers. All right, so you've had a second to look at the rest of the designs. For our second example design, we have soil type is our IV and our DV is germination speed. So if the only thing we're changing is the type of soil, well, ask yourself, what other things do plants need? Those things all need to be constant. What you got, Ms. Andrzejczyk?
So you've got to do it the same time of day. How much sun is that plant going to get? We need to have the same time of day. We also need to have the same amount of water that soil has in it. So that's not a change. What are the things that could it be, Miss Harris?
Well, we can't put a big old pile of soil into one of them and a little teeny amount into another one. So the amount of soil in the container needs to be the same. We can't use a terracotta pot for one of them and a styrofoam cup for another one and a plastic cup for another one. The water schedule and amount all needs to be the same. You can't water them, some of them a lot and some of them a little. Don't need that slash. Type of seed.
Oh, yes.
Can you imagine? Okay, yeah. So there are seeds that sprout in like 2 seconds. And then there's other seeds that take forever to sprout. Then there's seeds that won't sprout until they've been burned by a fire. Then there's seeds that won't sprout until they've passed through the digestive tract of an animal. It would not be fair to put one of those need to be burned seeds into this. It would never germinate just sitting in wet dirt. And if we tried to, we'd say, oh, that could be the best dirt ever for germinating seeds, but because we put that kind of seed in it, so you've got to make sure you're using the same type of seed. All righty. Third design. That's a good list. Of course, we could go on and on. Like, believe me, these lists, when someone is really designing an experiment, whoa. But this is backyard science, so we can keep it a little more simple. All right, in the third design, string length is our IV, and the number of swings per second is the DV. So the first thing you got to think about on this one is if I'm building a pendulum, what am I building the pendulum out of? So you've got to have whatever your hanger is. If you're tying it to the ceiling, if you're tying it to a ring stand, if you're tying it to the doorknob, whatever, it needs to be the same. What can you think of, Ms. Andrzejczyk?
I would say the thickness of the string would really been important, and that's called tensile strength, I believe.
Mm-hmm.
And we've also got to think about what kind of strength that we're using. Are we using fishing line for one and then maybe yarn for another?
And dental floss for the third one. No, you can't do that. It's got to be the same for all of them. Most of the time, a pendulum has to have a weight on it to get the string to hang down and swing back and forth. So whatever you're weighing down the string with needs to be the same. You can't use a washer on one, a bolt on one, a penny on another one. It's got to be the same weight each time.
It's got to be tied the same way.
Mm-hmm. When you're starting the pendulum, you're going to have to raise it up off the ground and then drop it. Whatever that lift height is needs to be the same. Because if you pick it like way up over your head for one of them, but only go eat for the other one, it's not going to swing very much. And did the string length affect the swings? Nope. It was how you did it. So you got to make sure you're doing it the same each time. I think that's, again, we could go on and on. That's a pretty good list. Video's getting long. We got to move on. All right. The last one, we're talking about the geckos, and food type is the one thing we're changing. The amount of food eaten is the one thing that needs to stay the same, or the amount of food eaten is one thing we're measuring. So what things need to stay the same? There we go. All right. So what would need to be constant? What do you think, Ms. Andrzejczyk?
Oh, well, not just fruit, but we need to know a certain kind of fruit. We have to use the same kind of fruit, I think.
Mm-hmm. So this experiment is actually kind of tough because either you've got to do right, or the brand. So like what I would recommend would either be, okay, we're only going to buy peaches, but we're going to do Gerber peaches and Great Value peaches and Beech Nut peaches and see which one he likes the best. Or you're like, okay, I'm only going to buy Gerber, but I'm going to do bananas, apricots, and peaches. So as long as one or the other of those stays constant, then you're good to go. Yeah.
How much fruit we're giving.
Oh, yeah.
Well, we're measuring how much. So
we're measuring how much he eats. So the amount offered would need to stay the same. You don't want to put a big old pile for one of them and then just a little bit for the other one. Time of day fed is really going to matter. These are geckos. They are nocturnal. So that means that they are awake at night and asleep during the day. So if I put in a thing of food at 8 a.m. and then checked it at 4 p.m. and he hadn't eaten any of it and went, oh, I guess he doesn't like that one, that would not be valid. I would need to put that food in at 4 in the afternoon and check it at 8 a.m. to see whether or not he ate it. He might have just slept all day.
Yeah, I got to do a little research to find out some of this stuff.
Yeah, and that's where that research step comes in, because we did talk about research in the last set of notes. You got to research. And then the location of the tray. Like you can't put the food tray down in one place for one type of food and then another place for the other. It's got to be the same. Again, we could go on for days on this. Oh, the gecko itself would need to stay the same, because some geckos, just like babies and people, some people like stuff and some people don't. All right, that's it. I'm going to call it into these notes. You're going to do the discussion. And, oh, is there more? There is more. Darn it. Okay. All right, strike that. We got one more. I forgot there was one more page. At least you know that this is the kind of stuff that would happen in class, right? All right, for an experiment to be reliable, it has to be repeated over and over. So reliable, repeated over and over many times with the same or similar results. You create this thing called the levels of IV to help you figure this out. So for the first design, it's already been done for us. You've got the levels of IV and the number of repeated trials. We've got cold water, hot water, and the control. There are some problems here. These should be in Celsius because we're in science class. And then the numbers would change because it's now Celsius. So this would be 1 degree Celsius water, and this would be 23 degrees Celsius water. Oops, I thought I'd done it in the middle. This would be 99 degrees Celsius water, and this would be 23 degrees Celsius water. But, anyway. Notice we have the number of repeated trials as 5. If we were conducting experiments and someone was paying us for it, we would need to do way more than 5 trials. If we were doing experiments on medicine or anything where it's like life or death, we're talking hundreds of thousands of trials before something can be said, yes, this is okay. But for backyard science, for school science, 5 trials is usually pretty good, because normally if something happens 5 times the same way, you can be pretty sure it's going to happen that way again. But you wouldn't want to bet money on it, so that's why they do lots and lots of trials when there's money put on it. So for our second design, let's look at this one together. We've got the levels of IV. We'll go here. And then the number of repeated trials. So then the top here are, what are your levels of IV? What are your soil types? You can write whatever you like as long as a type of soil. You can put wet, dry, and sand. It doesn't matter to me. I am going to put sand, expensive potting soil, and then dirt from the backyard. Dirt, BY, dirt backyard. Now, how many times are we going to test each of these? 5 in the sand, 5 in the expensive potting soil, and 5 in the dirt. All right, for the third one, this and this, always the same. Levels of IV, number of trials. Levels of IV, number of trials. All right, so here for string length, if string length is your IV, then your levels of IV are going to be different lengths of string. So we are in science class, so we're going to go with 10 centimeters, 20 centimeters, and 30 centimeters. And how many times for each one? That's right, 5. And then the last one for the gecko food type, we're just going to pick some food types. We're going to do peaches, apricots, and bananas. And again, offer each one of them 5 times. Okay, whew, sorry about that. Lots of false starts, or false stops, I guess. But we did it. Thank you for joining us. And now you're going to answer the discussion question, and then you're done with today's lesson.